In science, models are used to represent a system or parts of a system. So you are showing how something fits in contrast to the greater whole, how a particular item fits inside of a system of other items. And students can be expected to evaluate and refine models through the cycle of comparing their predictions with the real world and then adjusting them. So models that we make in science are going to be changing and evolving and adjusted throughout the process. So models are not art projects or static structures. If you create a model of the solar system, which is a thing that uses the word model, that's not what we mean when we are talking about developing a model. If you have your students create a model of the inside of a cell, that's not what we mean when we say model. If they, in one school that I taught at, the teacher would assign students to make a cell city. So there was like the power plant and there was the warehouse and all these different things. And I think that helped students and it helped them visualize, but that's not what we mean in the LSSS when we say develop and use models. So it's not that there's not some benefit to that, it's just that's not a model. What a model is it's something that is visual. It doesn't have to be tactile. It can be a drawing, it can be dots, it can be an equation. It represents a process, something happening over time, or a system. So if you have students model the idea of cell transport and bulk flow or osmosis inside of a cell or through a cell wall, that's creating a model as opposed to just having them draw a picture of a cell. But the process of bulk flow or osmosis is modeling how materials move within a cell. Models are revised over time as student knowledge increases, and they are tools for you to gauge what your students are understanding. So you'll be able to look at them and see that over the course of the unit or the course of the module, the week, students are increasing their understanding. And this is, again, part of the official LSSS, or in this case, NGSS materials. But you can see for your own grade band what this should look like. Modeling in K2 builds on prior modeling experiences. Modeling in 3.5 builds on K2. Modeling in 6.8 builds on K5. And it will tell you approximately what this should look like in your particular grade band. And you have, I think I sent those as well. So take some time to look at them in more. So let's look at mystery science, and we'll look at this lesson on clouds. And I apologize if you're saying I feel a little bit backed up because I don't remember doing this lesson on clouds. If we pull up these materials, there's an activity embedded halfway through where a student takes a clear plastic cup and pours hot water into it. And when the hot water enters and then you put a cap on the cup, the steam rises and you create a little mini cloud. So the question is, does that activity, does the cup and hot water activity pass the model test? And so we go back, our model test is it visual? Pouring hot water into a cup, is that visual?
Yes.
Is it a representation of a process or a system? Pouring hot water into a cup, you're watching the steam rise. Is that representing a process?
Yes. Yes.
Yeah. Is it revised over time as student knowledge increases?
It can be.
Pouring the hot water into the cup, you can revise that, and
or maybe how quickly they put the lid on, but that would be.
That's just getting it. That's just getting the process right. That's not
okay. Got it.
And is it a way for, as you watch students do that, can you gauge their understanding?
I would say so.
How?
So I guess because it's a visual, so like they could see the actual process instead of just reading about the process. I would say them actually seeing the process, they'll remember it better as opposed to them just reading about it.
Mm-hmm.
Am I onto something?
So I would agree that it's a worthwhile thing to do, and I am not suggesting to scrap it. But if you have a student pour hot water in their cup and then cap it and steam rises in the cup, I don't know as a teacher if students understand what they're supposed to be taking away from that, or if they just think it's cool.
Got it. Now, would it have to meet all four of those expectations to be considered a model?
Yes.
Got it.
So this is not what we are talking about as a model. This is a good activity to do, and it can be part of your explore. It can be part of your engage. It can be included in, because having that physical visual is a good idea. And I'm not telling you to scrap it. What I am saying is that this does not pass the model test.
Okay.
So my question is, which question below allows students to create a model about clouds? Which of these would allow them to create a visual that is revised over time, that allows you to check their understanding?
How clouds are formed?
Okay. Thoughts?